solve some radical equations. Consider the square root of v plus 4 equals 7. To cancel out a square root, we will square both sides. Whatever we do to one side, we will do to the other. So on the left-hand side, the square root cancels with the squaring, which would leave you with v plus 4. On the right-hand side, 7 squared is 49. So one more stage to isolating our gift here, finding out what the v is. We're going to subtract 4, and that would leave us with v on the left and 45 on the right. Now with radical equations, it is necessary, it is non-optional to not check your answer. You must check your answer because sometimes we will land on extraneous solutions. In class I'll tell you when those things happen and why they happen, but for practice here we are just going to check it without even thinking. We're going to just take a check here and see. So square root of v, which we think should be 45, plus 4, is that equal to the number 7? 45 plus 4 is 49, and the square root of 49 is 7. So our check worked out, and this does allow, this is a correct answer. So the final answer is v equals 45. Pause the video to try this one on your own, and then we'll do it together. Together we have the square root of y plus 5 equals 5. So just like before, I'm going to square both sides for the purpose of canceling out the square root. Once you square the square root, they cancel. Get a y plus 5 here. And on the right hand side, 5 squared, or 5 times 5, is 25. Now subtract 5 from both sides for the purpose of isolating the variable, and it appears as though y is equal to 20. Before we leave, let's check to make sure. If we check, the square root of y, which is apparently 20, supposedly 20, plus 5 equals to 5. 20 plus 5 is 25, no problem there. Square root of 25 is 5, and that looks like a good check. So we weren't assuming, we got down to the end, and 20 is a valid solution to this radical equation.